In this part of the lab, we are going to make 4 different treatments. We're going to put Chlorella vulgaris in an autotrophic treatment with BG11 medium, a heterotrophic treatment with BG11 medium and glucose added, a mixotrophic treatment with BG11 medium and glucose added, and a phototrophic treatment with BG11 medium and glucose added. I'm going to add 1 milliliter of Chlorella vulgaris to each of the 4 treatments. Then I'm going to add 1 milliliter of glucose to the heterotrophic, the mixotrophic, and the photoheterotrophic treatment. To begin with then, I take a sterilized pipette tip, put it onto my pipetter, open up the lid of the Chlorella vulgaris culture, get 1 ml out, and place it into the autotrophic. Get rid of the tip, get a second tip, repeat with the Chlorella vulgaris culture in the heterotrophic, release my tip, and I would repeat that for the mixotrophic and the photoheterotrophic. Then I would do the same procedures with pipette tips and add glucose to the heterotrophic, the mixotrophic, and the photoheterotrophic. Now that we have our cultures inoculated, we are going to set them up so that they have 1 week to grow in different light conditions. For the photoheterotrophic, this top layer, we're going to place it in light. This has the light on all the time, so 100% light all the time. For the dark treatment, we wrapped it in aluminum foil. This is going to be our heterotrophic treatment that receives no light at all. For the mixotrophic, we're going to put it down here where this light is on a timer. Every 12 hours it will turn on and off so that the Chlorella vulgaris will grow in the dark as well as the light. Finally then, our autotrophic treatment, fully autotrophic treatment, and our photoheterotrophic treatment both receive full light cycles. We're going to leave it here for a week and come back a week from now. We allowed the cultures to stay for 1 week. We used pipettes and we bubbled in CO2 in the various items that needed CO2, photoheterotrophic, autotrophic, and mixotrophic. We left the heterotrophic without the CO2. After a week, we can see what's going on here. If we look at these cultures, here's our mixotrophic. It is slightly greener than our autotrophic. Our autotrophic has the least growth. Looks like our heterotrophic actually has more growth than our mixotrophic. And let's check out the heterotrophic. Heterotrophic has some growth. Looks like a little bit more than just a straight autotrophic, but not as much as the mixotrophic, and looks like our photoheterotrophic has the most. Now we're going to take these and we're going to use the flow cytometer to basically go in and analyze these. The next step is to use the flow cytometer to measure the lipid content of the various treatments. In order to use the flow cytometer, we need a specific number of cells, and that specific number of cells we're going to estimate using the spectrometer, similar to what we did in the turbidity analysis earlier in the semester. The spectrometer then, we need to blanket first. This is BG11 medium to blanket. I'm going to put BG11 medium in straight. We'll go up to experiment, calibrate the spectrometer. I'm going to skip the warm-up because it's already warm. I'm going to finish the calibration, and this goes quickly, and I'm going to press OK. Now I'm going to take this out and put in our sample. This is the sample from the autotrophic treatment. Put that sample in, and with that sample in, I just press play. I'm going to erase and continue, and there's what we have. Okay, I'm going to hit stop. Now our sample has to be between certain levels to get the right amount. The absorbance we're looking for is between 0.2 and 0.4, 0.02 and 0.04 absorbance, which is right here. This is our peak absorbance here. This is another peak. This is too high. It's about, what, twice? So we're at 0.08 instead of 0.02 to 0.04. So what I'm going to have to do is go back to our original sample, I'm going to have to pipette out half of this, pipette in half of BG11 medium, so that we get that down to 0.02 to 0.04 absorbance. Once we get it between 0.02 and 0.04, it will be ready for the flow cytometer to be used. Our next step is to prepare a sample for use in the flow cytometer. This is our flow cytometer. We are going to basically stain a sample using Nile red stain. Here's our sample from the buffer solution. Our first step is to take this sample, to take out 195 microliters of this sample, and to place it in the microcentrifuge tube. Our next step then is to take 4 microliters of the assay buffer, and to place those 4 microliters of the assay buffer into our microcentrifuge tube. I'm going to mix it up a little bit to make sure it's all set. Release the pipette tip, put this lid back on the assay buffer, and then our final step then is to take our Nile red stain, take 1 microliter of our Nile red stain, and to place that into our solution there. Return the lid to the Nile red stain, and we wait 5 minutes to allow that to get stained. Our final step is to use the flow cytometer to measure the lipid content in our various samples. We have our sample here that we prepared with Nile red stain. It's ready to go. I've mixed it up. It's all set and ready to go. Up here, there are a lot of different assays you can run in this. These are all pre-programmed assays. We have our algae Nile red assay that we're going to run here. We have 2 choices, run assay or view results. What you do with this is that you get everything set up, and you select cell size, and you select where you want to measure the results, and then you keep everything set for all of the different trials. So we're going to go in here to view results. This is our preset right here under Biofuels. I'm going to retrieve data. And you can see here that we've had a lot of different data sets in the past. So all of these are different data sets that students basically have taken from during the class in previous semesters. Okay, down here we have next run, so I'm going to hit next run. It says append to the data set. We want these data included in the overall data set. We're going to set the dilution factor. I diluted it 4 times, so I'm going to click 4 on that, and I'm going to apply that change. We then want to make sure that we use a code so that we know exactly what every sample is. A 1 up here indicates that this was an autotroph. Let's say we're group C or D within the class, and let's say that we're in section 015. Okay, all of that's ready to go. So now we want to follow the directions, mix and load the sample, raise sample loader, select run. So here's where our sample loader is. I take out the deionized water that it's in. I'm going to take our sample, put our sample in, lift this up, and it goes directly into the flow cytometer, and then we're going to press run. So first our system primes. Okay, it's getting all ready. Once it's ready, then it's going to start counting. Okay. We do have a little bit, it's a little bit dilute, but it's going to run it anyway to give you an example of what's going on so that we get this just right. So we can see here all of these little red dots are basically the chlorella vulgaris cells that have been stained. Over here we have 4 different quadrants. We have a chlorophyll high lipid low, chlorophyll low lipid low, chlorophyll low lipid high, and chlorophyll high lipid high. This is the quadrant that we want right here. Okay, so these are going to be the high chlorophyll and high lipid content cells. In all of our treatments then, the treatment we want would have a lot of cells within that quadrant. Okay, now that we're finished, then we want to basically collect our data. So here are the data that you want to record. So here we have our sample. This is sample 1, which is an autotroph. Group D, it was from section 015 for the students. Over here then we have percent gated, mean intensity relative lipid content, mean intensity relative chlorophyll content. We have 4 different quadrants then. We have quadrant 1, chlorophyll high, lipid low. Quadrant 2, chlorophyll high, lipid high. Quadrant 3, chlorophyll low, lipid low. And quadrant 4, chlorophyll low, lipid high. Percent gated then means the percent of cells that fell within that quadrant. So we had 35% of the cells that were lipid low, chlorophyll high, 13% lipid high, chlorophyll low, 43% lipid low, chlorophyll low, and 8% lipid high, chlorophyll low. We're interested in the quadrant of chlorophyll high and lipid high because that's, the fastest growing cells that are making the most lipid. Down here then, under this quadrant, chlorophyll high, lipid high, then we have the reading of the gate, percent gated, 13.20. We have mean intensity or relative lipid content being 88.6. Okay, then if I click up here on sample info, for the same sample we have cells per microliter, 432.57, and in this case the dilution factor. So you should record the dilution factor, the cells per microliter, the percent gated, and the mean intensity or relative lipid content.